So sometimes they may not use one of those four that you expect to memorize, and instead they'll give you one which they don't expect you to memorize, but they'll tell you what it is. Sometimes they'll write in summation notation. Sometimes they say the Maclaurin series for natural log of 1 plus x is x minus x squared over 2 plus x cubed over 3 minus x to the fourth over 4 plus, and they give you the general term right here. So they're giving you the whole thing because they don't expect you to have natural log of 1 plus x memorized. And then they're saying f of x is natural log of 1 plus x to the fourth. Very similar to this, except notice one key difference. X to the fourth is in place of x. So again, it says write the first four non-zero terms and the general term of the Taylor series about x equals 0, which again is a Maclaurin series, really. So just like the other ones, we have to modify it. Wherever there's an x, it gets replaced by x to the fourth. So we'll have x to the fourth in place of that x, minus x to the fourth squared in place of this x, divided by 2, plus x to the fourth cubed over 3, minus x to the fourth over 4, plus, and then negative 1 to the n plus 1, x to the fourth to the n over n. And then we can just simplify that a little bit. So we get x to the fourth minus x to the eighth over 2, plus x to the 12th over 3, minus x to the 16th over 4. There's our first four non-zero terms. Plus negative 1 to the n plus 1, x to the 4n over n. So you modify it in the same way. It's just they give you one, you're modifying instead of having to use one you've memorized. Again, if you want to check to see if it works, you could try plugging in 0, but then notice divided by n, plug in 0, that's not going to work, is it? So this is one where you actually start 1. If you plug in 1, notice it'll be negative 1 to the second, which is positive. First term is positive. Plug in 1 there, that's x to the fourth, divided by 1. Substitute in 2, you get negative 1 to the third, which is negative, so the second term is negative. Plug in 2 there, that's x to the eighth. 2 there, that's 2. So you can see that form of general for the general term does work. Okay. Now let's take a look at if we are given one where they tell you the sum, or basically asking you for the sum of this series, is which of the following. Okay. This is another one where they really expect you to have those first four memorized to figure this out, to know which one it goes with. You don't really have time on the AP test to derive each of these options here. So look at what we have. Well, it's alternating, right? And you can see the exponents are even. Notice that this fits the pattern for sine. Sorry, not sine. The one function that's even is cosine. Sine is an odd function, right? So this is the pattern for cosine x. But notice we don't see the x because the x would usually be right here where all the e's are. So that's your clue that it's just cosine of e. It fits the pattern for cosine. Just e being plugged in for all the x's. And that's it. If it was sine, you'd see the alternating pattern with the odd exponents. If it was e to the e, you'd see it all positive, not alternating, with no missing terms. And if it was 1 over 1 minus e, you would see, well, this one actually would diverge because e is not between negative 1 and 1. The common ratio would have to be between negative 1 and 1 to fit the pattern. So in that case, if this fit the pattern for 1 over 1 minus x, it would actually be non-existent if e was plugged in, because e is not about 2.7, it's not between negative 1 and 1. All right, and that concludes the notes for AP Calculus on the topic of the common Maclaurin series.